Hello, and welcome to this webcast. My name is Chetan Kapoor, and I'm a product manager with our PXI marketing team at National Instruments. As the title suggests, in this webcast, we're going to take a look at how you can use NI PXI Express hardware to build high-speed data record and playback systems. These systems can be used to address the needs of a variety of applications such as RF record and playback, intermediate frequency or baseband streaming, high channel count data acquisition, and also for various technology researches. More specifically, I'll talk about how you can use high-throughput PXI Express instruments, chassis, and controllers from National Instruments to create these type of systems that'll give you the capability of streaming to and from disk at up to 2.8 gigabytes per second data rates. As I had mentioned previously, there are various applications that can benefit from this capability. In China, for example, a company named Chengdu Huawei Telecommunications Company developed a solution for spectral monitoring of RF signals inside and outside government-regulated frequency bands. National Radio Astronomy Observatory in the U.S. Uses high-speed record and playback hardware to help develop signal processing algorithms that can be embedded in the FPGA to work in tandem with their next generation high performance radio astronomy receivers. Averna uses NI PXI Express hardware to actually create a standard product for GPS record and playback applications. Specifically, this hardware is actually designed to be used in doing the validation process of a specific design of a consumer electronics in order to make sure that the design is functioning properly. This slide represents the architecture of a typical record and playback system. Such a system would typically include an ADC or a DAC to actually physically interface to the signal. The ADC is going to have to interface using some custom or serial protocol to a physical interface. These two components together typically represents instruments, a specific instrument in this case. The instruments need to interface to a system or host computer, and the system or host computer is going to actually contain the interface to a set of hard drives to actually record and play back the data. In the case of various platforms, the actual bus, or the data bus that are actually used to move the data from the instruments to the system or host computer becomes super critical as it actually defines the overall capability of the record and playback system. So let's take a moment to actually compare the different physical data buses that are available that allow you to interface some kind of instrument to a system or a host computer. This slide represents the various buses that are available, and they have been categorized by using two vectors. The first one that is on the y-axis represents the overall bandwidth in terms of megabytes per second. The x-axis actually represents the latency in terms of microseconds. And if you would see, PCI Express is on the top right. That would mean it actually offers the highest throughput with the lowest latency. This bus therefore makes it as an ideal bus to be used in high-end record and playback systems. PXI Express systems actually incorporate the PCI Express bus in the backplane to allow you to create these high-performance systems. So let's take a quick look at PCI Express. PCI Express is a point-to-point high-speed serial bus that is actually backward compatible with PCI. It is available in different modes. PCI Express Gen 1 actually has the signaling at 2.5 gigabits per second. In the evolution of PCI Express, which is called as Gen 2, the signaling rate is actually 5 gigabits per second. In PCI Express, you have the option to aggregate multiple lanes to create a higher throughput link. And PCI Express also, has a roadmap for Gen 3 clocking, which is at 8 gigabits per second with a different encoding scheme The data rates from Gen 2 to Gen 3 double, similar to how the data rates actually double from Gen 1 to Gen 2. So let's take a look at some of the example theoretical maximum transfer rates that PCI Express offers. In a by 4 PCI Express link of generation 1 type, the maximum theoretical unidirectional transfer rate is 1 gigabyte per second. So that would translate to a bidirectional throughput of 2 gigabytes per second. A by 16 Gen 1 offers 4 gigabytes per second of unidirectional throughput and 8 gigabytes of total throughput. As I mentioned previously, jumping onto Gen 2, Gen 2 actually offers the double the data rates of a Gen 1 link. So a by 4 Gen 2 link actually offers 4 gigabytes per second of theoretical maximum unidirectional throughput rate with 4 gigabytes per second as the total throughput rate. So let's take a look at PXI Express and how it utilizes PCI Express to allow you to create these high-speed data record and playback or high-speed data streaming systems. As a quick refresher, in a PXI system or a PXI 1 system, as some people would refer to, the data bus that is actually utilized to move data between all the instruments in a PXI chassis to an embedded controller is PCI. PCI in its 33 megahertz 32-bit implementation offers you a total of 132 megabytes per second of data rate. In the case of PXI Express, there are actually 4 by 4 PCI Express links that interface the embedded controller or the host controller to the chassis and thus all the instruments in the chassis. These 4 by 4 Gen 2 links give you a total system throughput of 8 gigabytes per second. This represents a 60x improvement over the capabilities of a PXI 1 system. Now let's take a look at the 8133 embedded controller that actually plays a critical role in allowing you to create these high throughput systems. So in the case of 8133, there's an Intel Core i7-820QM processor that is actually onboard memory and PCIe controllers. The PCIe controller actually forwards a by 16 Gen 2 link that is broken down into 4 by 4 Gen 2 links using a PCI Express switch. The memory controller offers 2 channels of DDR3 RAM operating at 1333 megahertz. Both of these components together allow you to offer 8 gigabytes of total system throughput. So in the case of a balanced high performance streaming system, the amount of memory throughput that is available and the amount of total RAM that is available is a very critical factor, and it is required for that capability to match the capability of the PCI Express controller. Now let's take a look at the PXI Express 1082 chassis from National Instruments and understand its capabilities. So if in the chassis you have an 8133 embedded controller, then slot number 1 to which the embedded controller is placed in will actually forward 4 by 4 PCI Express links to the backplane. In the backplane has the capability to absorb these 4 by 4 links and actually route them to specific slots. The first by 4 link is directly connected to slot number 2, and then the other remaining by 4 links, or the remaining 3 by 4 links, are actually forwarded to a PCI Express switch in the backplane, and each switch connects to 2 downstream devices. With the use of 4 by 4 PCI Express links in the backplane, the 1082 chassis offers 8 gigabytes per second of system throughput that actually matches well with the capabilities of the 8133 embedded controller. In the previous few slides, we talked about how PXI Express chassis and controllers, or PXI Express system components, can be utilized to offer this high throughput infrastructure for creating these high speed record and playback applications. Now let's take a look at some of the modules or instruments that are available from National Instruments that will actually allow you to bring in I/O or generate I/O and eventually store it to disk. To begin with some of the storage options, National Instruments offers the NI 8260 in-chassis storage module. This module is 3 slots wide and has capability to absorb 4 2.5-inch drives, SATA drives. So in the case we're using 4 hard drives, you can get storage speeds of up to 200 megabytes per second with a total capacity of 1 terabyte. We also have an option available where we utilize SSDs or solid state drives. In this case, with the use of SSDs, you can get 400 megabytes of streaming to and from disk data rates and a total capacity of 256 gigabytes. We also have a couple of other products that are interfaced externally to the chassis. So this is the NI 8263 and the NI HDD 8265. The 8263 consists of 4 hard drives that are 3.5-inch hard drives that are externally connected or externally interfaced to a PXI Express chassis. This specific product is capable of storing data at 200 megabytes per second and offers a total storage capacity of 2 terabytes. The 8265 uses 12 hard drives to offer 750 megabytes per second of stream to disk data rates and a total capacity of 12 terabytes. National Instruments offers a variety of I/O devices that can actually allow you to interface to physical signals. We have this PXIe 6544 and 45 HSDIO products for high-speed digital interface. The 5442 arbitrary waveform generator, the 5122 high-speed digitizer, to talk about some of the products in the digital and the IQ/baseband range. For spectral monitoring or RF spectral record and playback application, National Instruments offers the 5672 VSG and the 5661 VSA. Both of these products are capable of streaming data at 100 megabytes per second. To offer increased frequency range and measurement bandwidth, NI offers the 5673 VSG and the 5663 VSA products. These products are capable of streaming up to 500 megabytes per second in the case of the VSG and up to 250 megabytes per second in the case of VSA. National Instruments also offers the 5450 IQ generator and the PXI Express 5622 IF digitizers. Similar to other products, these products are capable of recording data at high throughput rates. In the case of 5450, for dual channel implementation, you can stream data at 600 megabytes per second. In the case of the 5622, the data rate is 300 megabytes per second. The previous products that I highlighted were products that offered fixed functionality. To provide the option to create instruments that the user can program to better meet their needs of their application, NI offers the PXI Express FlexRio modules. These modules are currently based on Xilinx Vertex 5 FPGAs and can be programmed in an abstracted graphical environment offered by LabVIEW instead of a low-level HDL-based environment. These modules can be used either as coprocessors or also as an I/O module by using adapter modules that plug into the front of this module. The NI FlexRio FPGA modules can stream data at 800 megabytes per second to system host or directly to certain NI instruments via peer-to-peer streaming. Now let's go through a quick demo. In this demo, I'm going to showcase how you can use PXI Express hardware from National Instruments to create streaming systems that can sustain 2.8 gigabytes per second of streaming to or from data rates. In this demo, I have 4 PXI Express 7965R FlexRios that are going to be streaming data into system memory. Once in system memory, this data is going to be transferred to 4 RAID arrays, specifically the NI HDD 8265 storage devices that are interfaced to the PXI Express chassis via the NI 8262 interface modules. On the left, I have four Rio resources names that actually refer to the four PXI Express Flex Rio modules that I have in the chassis. The RAID arrays in Windows simply appear as logical drives. So I have files on each of these logical drives to actually store the data from the four Flex Rios. I'm going to be acquiring a total samples of 10 gigasamples, with each sample being 8 bytes wide. And my total transfer rate for a specific stream is going to be 700 megabytes per second. So let's go ahead and run the VI. As you can see, in this case, we are streaming data at the required transfer rate of 700 megabytes per second. So collectively, that's 2.8 gigabytes per second of streaming data to disk for a total theoretical throughput of 5.6 gigabytes per second. This bar actually indicates the total acquisition progress, with its length representing the total number of samples that we intend to acquire. So in this case, we are almost a third way through. So we have approximately written around 3 to 4 gigasamples of data to disk. The 8265 products, each of them have 12 terabytes of storage space, for a total storage space in this system being 48 terabytes. And at the rate of 2.8 gigabytes per second, we can sustain that specific rate for approximately 4 hours and 45 minutes. I'm going to go ahead and stop the VI. And that actually exits the specific demo. To summarize the demo, we were utilizing the NI PXI Express 1075 chassis with an PXI Express 8133 embedded controller. We had 4 Flex Rios streaming at 700 megabytes per second into system memory, and that data was transferred back down to 4 RAID arrays recording data at 700 megabytes per second each. This translates to 2.8 gigabytes per second of upstream bandwidth and 2.8 gigabytes per second of downstream bandwidth for a total system throughput of 5.6 gigabytes per second. To summarize the session, PXI Express system components from NI use the latest PCI Express Gen 2 standard to offer 8 gigabytes of total system throughput. For creating high-speed streaming to and from disk applications, this hardware products can be used to sustain streaming rates at 2.8 gigabytes per second for over 4 hours. To learn more about PXI, please visit ni.com/PXI. And to learn more about high-speed streaming, please visit ni.com/streaming.